Now that you've learned how to multiply polynomials, sometimes when you multiply polynomials, you get what is called a quadratic equation or a quadratic function, and that's what we're going to look at today. Now, let's back up. I want you to make some changes to your packet here. Take out standard form and write slope-intercept form there, and take out the a and write m. So it should say, remember the slope-intercept form of a linear function, y equals mx plus b. Now, we learned about that, and we learned that the m part of that is my slope, and the b part of that is my y-intercept. So I could graph that equation if I needed to. Now, the standard form of a quadratic function is y equals ax squared plus bx plus c. Now, what makes this a quadratic function is that the highest power in this equation is 2. So ax squared. Now, sometimes we will get a quadratic function that has 3 terms, which is called a trinomial, just like I've written here. But sometimes we may get a a quadratic equation that's a binomial. It only has 2 terms. And in that case, it may look like ax squared plus bx, or it may look like ax squared plus c. Or we may even get a monomial, which is a 1 term. But they're all still quadratic equations. Now, what we're going to look at today is binomials, quadratic binomial equations. But before we do that, we're going to look at the graphs of quadratic equations. Quadratic equations always form the same kind of a graph, and it's called a parabola, and that's a U-shaped graph like I've drawn for you here. I've drawn a red one that opens up and a blue one that opens down. Now, what makes those open up or down is the coefficient of the x squared term. Now, coefficient is the number in front of the x squared term. So if the number in front of the x squared term is positive, the graph will open up like the red parabola that I have drawn. If the, sorry, I pressed the wrong button. If the coefficient of the x term is negative, then the parabola will open down like the blue parabola that I have drawn. Now, the vertex of a parabola is the highest or lowest point. So it's where the graph changes direction. So if I look at my red graph there, the vertex is at 1, -2, and the vertex is always a point, so you express it as an ordered pair. Now, if on my blue parabola, notice that my vertex is my highest point, and it is 2, -1. Now, whether it is the highest or lowest point tells me whether the parabola has a minimum or maximum. If the vertex is the lowest point, that is a minimum. The parabola has a minimum. If the vertex is the highest point, then the graph is said to have a maximum. Now, the axis of symmetry is another part of a quadratic function graph, and that is an imaginary line that runs right smack down the middle of my parabola, and it's a vertical line, and it divides the parabola into 2 symmetric parts. And remember that the equation of any vertical line is x equals some number. So if I look at the line that goes right down the middle of my red parabola, that has the equation x equals 1. Notice that that 1 is the same as the first value of my vertex. Now, if I'm looking at my blue parabola, the axis of symmetry that goes right down the middle of that is x equals 2. Again, notice that that x equals 2 is the same number as the x value of my vertex. Now, to find the solution of a quadratic function by looking at a graph, you look at how the parabola touches the x-axis, because the solution to a quadratic is the x values where the graph crosses the x-axis. So I'm looking at my first graph there, and notice that the parabola doesn't touch the x-axis at all, so that has no solutions. On the second graph, the parabola touches right at the vertex on the x-axis, so that has one solution. And on my third graph, the parabola crosses the x-axis twice, so that has two solutions. So any quadratic function can have 0, 1, or 2 solutions depending on how many times it touches the x-axis. Now, let's use some of this stuff. I've given you a graph here, and I've given you the quadratic equation y equals 2x squared minus 4x, which goes with this graph. I'm going to look at the coefficient of that graph, and remember, coefficient is the number in front of the x squared, and it is a positive 2. So that graph should open up, and sure enough it does, because it has a positive coefficient. The number of solutions, the graph actually touches the x-axis twice, so there are 2 solutions, and the ordered pair for each of those solutions, one is 0, 0, and one is 2, 0. The vertex of this parabola is my lowest point there, and that is 1, negative 2. And since it is the lowest point of the graph, that is a minimum. And the axis of symmetry is the line that cuts right down the middle. The equation of that vertical line is x equals 1. Notice that's the same as the x value of my vertex. Now, make sure you have all of this written down, and then we're going to go to graph B. Graph B has the equation y equals negative x squared plus 4x minus 5. Now, this is a trinomial, but we're still looking at the same sort of things. We're looking at the coefficient of x squared. Well, if I'm looking at the coefficient of x squared in this equation, it's a negative, but that's really a negative 1. We never write it down, but it is. And since it's negative, this graph should open down, and it does indeed. Now, the solutions, notice that this graph doesn't touch the x-axis at all, so there are no solutions, or there are none. And so the next one we can just kind of cross off. It's not applicable. The location of the vertex of this parabola is this highest point where it changes directions at 2, negative 1. And since it is the highest point, that's a maximum. And the axis of symmetry is the equation of the line that cuts right down the middle of this guy, and it is x equals 2. Notice that that is the same value as the x value of my vertex. All right, now I want you to try this next one out on your own, and then come back and compare your answers to mine. Pause your video now. Okay, now that you've had a chance to do this, you should have said, hey, the coefficient of x squared, since they didn't give me an equation, I don't really know what it is, but I know it has to be negative because my graph is opening down. It has 2 solutions because the parabola crosses the x-axis twice, and the location of those solutions is negative 2, 0, and 4, 0. The vertex is the highest point, and it is 1, 9. And since it is the highest point, it is a maximum. And the line that goes right down the middle of this is my axis of symmetry, and that is x equals 1. I think you have what you need to go work on some of your practice.